research for the McGregor Company. So today I'm out near Walla Walla and I was putting in flags that is ultimately going to be our winter wheat variety trial, seed treatment trial, and fertility trial here outside of Walla Walla. And what I've decided is the fertility that's down at this particular location, we're going to use this as our high yield attempt. And it really got me thinking about effective nitrogen management and what's been working in the Pacific Northwest, in our research plots, in our customers' fields, and some things that maybe are a little bit more risky. So if nitrogen management is a concern for you, then I think this will have some interesting information for you. So really what got me thinking about this topic as I was flagging the plot, well, lots of flags out there, was I was putting in just taking a soil temperature reading. Any guesses where we're at? So this is 4 inches down and I'm sitting right at 70 degrees. And that's going to come into play when we talk about nitrogen management. The last couple years, we've been able to average over 150 bushels in our Walla Walla site. And this ground we were on 3 years ago and we had some lodging issues. And part of that Matt's wheat yield project that I've been a part of is how do we spoon feed that crop nitrogen and use PGRs and fungicides to really amplify the effect of nitrogen. And one of the big key take-homes of the meetings that I went to in Chicago was as we have inputs like fungicides, like nitrogen stabilizers, we're actually changing the nitrogen response curves that we traditionally get on that farm. So what I mean is, if, say, that farm traditionally stops reacting at 120 pounds of N, with things like fungicide adds and nitrogen stabilizers, we're able to push that to, say, 150 pounds of N, but consequently, get yield responses all the way up to that. And I had a post up on Twitter earlier about in our research plots, if we set a yield goal of, say, 100 bushels, and we take our soil tests and we do the calculations on what our needed nitrogen is to hit that yield target, when I use nitrogen stabilizers, 100% fall applied, so that's pre-plant shank below the ground, we don't do surface applied very often here, I have traditionally or historically more consistency stabilizing that 100% fall applied application than I do split applying those applications. And what I mean by that is I'll take maybe 60% of what I assume my total N will be, I'll put that in the fall, and then I'll kind of spoon feed the rest of that out in maybe a 30-pound top dress and a 20-pound later in the season. What I've found is that in the Pacific Northwest, our rains tend to be super inconsistent in the spring, right? And the first couple times I saw the anomaly of my split applied nitrogen applications not doing as well as my 100% fall applied, I kind of brushed it off because I assumed my timing was wrong on my research plots. And I have tried everything from early March to the end of April, and I have yet to beat my 100% fall applied with a stabilizer. Remember, those stabilizers are something like Prolong N or an Inserv, and what they do is they help keep that nitrogen in the ammonium form longer, immobile ammonium form, before it converts to nitrate. The reason we looked at that soil temperature is that conversion, historically we think of that conversion stopping around 50 degrees in soil temperatures. There's research to support that conversion will happen all the way to 40 degrees. Regardless, we were at 70. And if I look at the historic averages at this location, it's going to be closer to November before we have consistent soil temperatures below 50. So that means we've got 6 to 7 weeks yet of that nitrogen being in the ground, where if we get rain events, we can start getting quite a bit of conversion in that soil from our immobile form to our mobile form. What that means is as we come into spring, that nitrogen is going to be driven farther and farther and farther into the soil profile, and our crop is likely not going to have roots far enough down to catch that nitrogen. Being able to hit that early tillering and that stem elongation are critical, and I feel like in this environment where we have limited rainfall, we have to be able to use these nitrogen stabilizer products below ground so that we consistently hit that target into stem elongation. So I hope that makes some sense on where my head is with nitrogen management, high yield, and why nitrogen stabilizers are super important this fall. I'm traveling